In the last video, we saw how to set up the overloaded unary minus operator. And we also have, actually, if you look in the book, you'll see the overloaded subtraction operator, which looks a lot like the plus operator, not much different. So here's how you would use both of these operators. And remember, the book in the very beginning sets these up as standalone functions. So here's how we set up three objects. One is amount1. It's an instance of the money class and initialized to having $10. The second is amount2, which is initialized to having $6. And then the third one, this is actually, remember, this is actually does actually create an object, only it's using the default constructor. And remember, in C++, you do not have to use empty parens to call the default constructor. You just say money and then name of the thing. It actually does call the default constructor. Okay, so here's how to use the subtraction. You're just taking two objects and subtracting one from the other. And we can do that as long as we have defined, in this case, a standalone function to overload the subtraction operator. This will have two arguments. So you'll have a minus operator that's overloaded, an overloaded function, standalone function with two operands. This is the first one, this is the second one. And if you were to do this, you would subtract the 6 from the 10 and it should display $4 for, if you call the output member function. If you were to say that account 3 is minus amount 1, then this is a call of the unary minus operator, which what it does is negate whatever is in amount 1. And of course we can define it to do anything we want, but that's probably the thing that makes sense. Negate each of the dollar and cent data members. And once you call this, so a nice thing of course is that you're saying negative of an object. So can't stress this often enough. We do not have this in Java. It would be nice, but it's not really necessary. We can always call a member function, member method, in Java if we need to. But this looks nice. We're saying some object is equal to minus some other object. And it's just sort of makes sense to read code like this. If you were to print it out, it should display the negative of whatever is in amount 1, and that was $10, so it should display negative $10. Okay, so the way the book treats overloading, it looks at overloading as standalone functions first, and then later on, only later on, does it look at member functions, which we looked at in the second video of this lecture 9 series. We saw how to use saw how to set up the member plus or binary addition operator. The binary operator plus for addition. Okay, so far in the book, all of the previous examples were standalone functions defined outside a class, but as you probably already know, we can overload as a member operator, and these are considered just member functions, just like any other member functions. So when the operator is a member function, now one of the operands is the current object, this. And so therefore we only need one parameter for something like plus or minus. So it looks a little bit odd in that we have a plus. If we have a member operator, we only have one operand. But remember, the calling object serves as the first parameter. Or you can think of it as the calling object is the first or the left-hand side of a binary plus or a binary minus. Okay, so how would we set up the plus operator? We did that in the second video in this set of lecture notes. And let's say we have two objects, cost and tax, with different dollar and cent amount. And the way we want to use the plus operator, just like with standalone function, is the same way. There's actually no difference. We say that one object plus some other object. If this plus is overloaded as a member operator, then we only have, this is like saying plus, sorry, this is like saying cost dot plus and then in parentheses tax. So this object tax is the only argument that you need. So here it is. So you can think of it as total is equal to cost dot, so using a dot notation like in Java, to access a member operator plus, and then the one parameter, which is the right hand side of the plus. And inside the class definition, this is how it would look. You would have a const money object as a return type, and we'd say operator plus, and then in parentheses just one argument. So you might say, well, when do you make a function const? Const functions are not allowed to alter the class data member, and sometimes that's what we want to make our programs bug resistant. That's to make it more safe. And so const objects, if you have a const object, you can only call const member functions. That is, member functions that are guaranteed not to change anything in that object. So it's always desirable if you can make any function const do it, and it's a good style. Good style dictates that any member function that will not modify data members should be made const. How do you do this? You just use the keyword const after the function declaration and heading. So we haven't had to do it so far, but if you had to do it, what does this last sentence mean? It would mean something like this. Where can we do this? Okay. If we were able to do it, which we can, you'd say const right there. All right. And I believe if we don't do this, let's try compiling without putting a const there. I'm thinking we'll get an error message. Yes, we do. You can fix it by putting a const. And that takes care of it. So it's unfortunate that we have to do it in both places. We have to do it in the .h file, our interface file. .h is called an interface or header file. We have to do it here, and then we have to repeat it in the implementation file or the .cpp file. Without that, as we saw, we get an error message. And so this is something, a lot of times it will be required by the compiler. Sometimes it's not required, but you should still, as much as possible, any member function, always try to put it in. Of course, you can't always do it because a lot of member functions are meant to modify data members. And so whenever you have a member function that modifies a data member, you cannot use const. Okay. So use keyword const after the function declaration and heading. Okay, so you might say, well, when we overload operators, which method should we use? So according to this way of programming that we use, that is object-oriented programming, these principles suggest that we should use member operators. So for example, we would say that the plus, if you want to implement binary addition, that is addition of two things, you want to define that to be a member operator, just to maintain the spirit of object-oriented programming. Member operators can also be more efficient. We don't need to call get methods and set methods, because when you define a member operator, you can access those data members directly. So what are we talking about? Oops. If you look at this, we didn't have to use a get method to access this data member. Whereas if you look at the money, the implementation of the money standalone plus operator, you will see a lot of get methods. Let's take a quick look at that. So I'm going to scroll way back to when we looked at the money standalone plus operator. There's a whole lot of get methods. Get. And then once we do that, so this is inefficient. Anytime you have to call a function or a method or a member function, that's going to be less efficient than just accessing the data members directly. Okay. So member operators are more efficient. So two things that suggest that we should probably use member operators as opposed to standalone operators. But there's at least one significant disadvantage which we will look at a little bit later in this chapter. So another thing that we can do is we can overload function application. So we can basically overload parentheses. So the function call operator, that is left right parens, must be overloaded as a member function. And this allows the use of class like a function. So it allows us to use an object just like a function. So for example, let's say we create an instance of the A class called an object, and we can call the any operator and anything that we want using what looks like a method call. This will only work if you overload the open close paren operator. This looks just like any other operator, only it's got two things to it. Well, I guess we've done that already with the equality operator. It has two equal signs as the name of the method or name of the function, and this is somewhat similar. You have left and right parens. So what is this bias? It allows us to use an object like a function. And so we can overload like all possible numbers of arguments. If you have multiple arguments, you can put them all in. So if you have two arguments, if you have, let's say you want to initialize for whatever reason you want to reinitialize that is this object, you can have if it has two data members, you can put both of them in. There are other things that you can overload. The AND, the logical AND, that's what the ampersand operator is, and the logical OR is the two straight lines, the comma operator. And these predefined versions work for bool types, but now we can AND two objects. So recall that we use short circuit evaluation. Sometimes we rely on short circuit evaluation for our Boolean expressions to work. So when overloaded, we no longer use short circuit. Instead, we use complete evaluation. What is that saying really? Remember that short circuit evaluation says if you have two things that we're ANDing together, right? If the first thing, that is the left-hand side of the AND operator, is false, there's no point in evaluating the right-hand side of the AND operator. And so the right-hand side will not get evaluated if the left-hand side of the AND is false. So that's short circuit evaluation. And so you want to keep in mind that when we overload the AND operator for a class for whatever reason, we no longer use short circuit evaluation. We use complete evaluations. That is, even if the left-hand side is false, we still evaluate the right-hand side of the AND. Now in the OR, it's just the opposite. Remember that with the OR, if the left-hand side of the OR is true, there's no point in evaluating the right-hand side, and so we don't when we use bool types. However, when you overload it, the short circuit evaluation is no longer valid, and so we use complete evaluation. That is, even if the left-hand side is false, we still do evaluate the right-hand side. Generally, there's no reason to overload these operators. Almost always you can get by without having these overloaded operators. Okay, next up we look at friend functions.